Welcome, everybody. I'm very happy to present to you today the first session of the course Designing Code Analysis for Large-Scale Software Systems. My name is Eric Bodden, and I will be delivering this course to you. As you can see, this is my cramped little home office. It's not very exciting. I don't know if I am that exciting to look at. So for the remainder of this course, I'll be focusing mostly on my slides. And let's switch over there and take a look at what I will be teaching you over the course of this term. So what we will be going through this week is the following. First, I want to say a few things about our group, what we do, why we are interested in code analysis, and why I think that it's a really exciting research topic and also a good topic to know about because it also has very important practical applications by now. Then I will also be talking about a brief introduction to static code analysis. And later on, I will give you administrative information. And I will also be talking about intermediate representations for static analysis. So intermediate representation is basically a representation of program code that is not quite source code and also not quite bytecode or machine code, but is something in between. And that is a representation that is very frequently used for static program analysis because that has a lot of advantages. And it's a very basic concept that we will be requiring throughout the rest of the course. So I will be covering this week as well. I will not be teaching this course entirely on my own. So the lectures will be delivered mostly by myself, but we are also having a few of my PhD students as TA for this course, so you will be in contact with them as well. Because we're doing this all virtually this year, you might not see them very often, but nonetheless, now you have seen what they look like, and hopefully you will get the chance to also see them live at some point. If not, they will be just as eager to address your questions and concerns online. We'll be talking a little bit later about how we are going to do this in this course. Within my research group, one important point is that we are developing a lot of research tools. And these are tools that are coming out of research, but some of them are actually very practical. And what you see here is a little bit of a tool landscape that we had built over the last few years. And as you can see, a lot of this tooling is actually related to this framework that you see placed in the middle, which is called SUIT. And SUIT is actually a program analysis framework that we will be using heavily. We have also been building another framework that I will still be talking about a little bit later, which is for the analysis of C and C++ programs in particular. This framework is called Phaser. And both SUIT and Phaser are going to be important parts of this course, at least when it comes to the practical side of things. These tools that we developed, they are relatively popular. So what you see here is sort of an already outdated hit counter from our webpage. So by now we got a lot more contacts there. But what you can see here is a sort of a nice qualitative picture. So these tools are really being accessed almost worldwide. There's a lot of traffic from Germany and the United States, as you can see, but also other countries are accessing this quite heavily. And as you can also see, India and China are a little bit darker. So program analysis research there has also become relatively strong in recent years. And there are increasingly many people using these frameworks of ours there as well. I've already mentioned the SUIT framework. So SUIT is one of the primary frameworks that we will be using in this course, but also in itself, it's very popular. So if you go onto SUIT's GitHub page today, you will see that there are more than 1,000 people who have started the framework, and there are several hundred forks, and many people also watching what's going on there on GitHub with thankfully a very active user base who is contributing to the project from researchers worldwide. And so I'm very happy to say that over the last 20 years that SUIT has existed, We have had many hundreds of researchers using Suit, so you will find that the appropriate papers are cited way more than 1,000 times. And also Suit has seen some industrial deployments in the last few years. So it's running in major app stores, for instance, to scan security properties of mobile apps, but it's also used for other program analysis purposes. Suit didn't originate in my research group, so I started working with Suit as a PhD student myself. So I actually did my PhD at McGill University in Canada, and that's actually where Suit originates from. So it was developed under the supervision of Laurie Hendren and Clark Verbrugge around the turn of the century. And Laurie happened to be my PhD advisor, so I was one of the earlier PhD students working with Suit, and then in the last 10 years or so, I've been slowly taking over Suit's maintenance with my group, and by now we are the group that develops Suit further, and it's also responsible for its maintenance. Then I also already mentioned the Phaser framework. So Phaser is a framework also dedicated to static program analysis, and opposed to Suit, it is not targeting the Java language, but rather C and C++. And Phaser is implemented as an extension to the LLVM framework. You may have heard of LLVM already. It's an open source compiler framework, which is largely backed by Apple, but also some other industrial partners and also academia. And yeah, LLVM itself, it's good for compilation. It's good for compiling different programming languages into, let's say, x86 machine code, for instance, but also other architectures. But we have extended it so that you can also do very powerful static program analysis on top of LLVM. And this extension, it's called Phaser. And in our practical labs this year, you will be able to choose among Suit and Phaser for some of the exercises at least, so that you can pick and choose what you are more comfortable with, Java or C and C++. And we will be discussing solutions for both of these frameworks. My group, as you can also see among the logos on the bottom, it spans not just Paderborn University and the Heinz-Nixdorf Institute, but also Fraunhofer IEM. Fraunhofer is actually Europe's largest research organization, so we are a lot more than 20,000 people right now, most of them working from Germany. And we are about 70 different institutes at the moment on different research topics. And Fraunhofer IEM and Paderborn is actually doing research in the area of mechatronic systems. And my group in particular is focusing on software and software security research in this area, but also beyond that. Yeah, what's important is that at Fraunhofer, we get measured not so much by doing foundational research, but actually by transferring that into industry. So there we are actually engaged in many collaborations with industrial partners, probably many of which you have also already heard of. So we are collaborating with companies that you see here on this slide, and some of them have actually started picking up also static analysis technology because of what we do. How do you find us? So normally right now you will find us mostly in our home office, but if you're lucky, you can also see us in the HNI building or with Fraunhofer in Zukunftsmeile 1. So that's the main Fraunhofer building where we're usually residing. And so what do we do in this research group? So the point is static analysis is an important topic in this research group, but it's not everything that we do, right? So we are generally interested in software engineering methodology. How do you design better software? But then one particular research question is how do you design a software engineering process such that you can actually also have secure software in the end? And there are many topics that play into this. So there are topics such as risk assessment, secure software engineering in general, but also usable security is a topic. It doesn't help if we are designing tools that are optimal from an academic point of view. They also have to be usable in practice so that people can actually engage with these tools and they can successfully make use of them in their development practices. And that's also very important for us. So we are actually conducting user studies, for instance, also with code analysis tools to make sure that they deliver what was promised. We are also working on topics such as usable cryptography, security and type systems, but occasionally we will even be engaged in projects that have nothing to do with security at all, where it's more about assuring other helpful properties in software engineering processes. That's all that I wanted to say about our group. I will then next continue with an introduction to static analysis.